Hello, everyone. A very good afternoon to all of you. I am Ella, welcoming you all on behalf of Solar Quarter and First View Group to Next Gen Solar, unraveling the latest developments in PV technology in Southeast Asia. I take the pleasure of thanking our panel members for extending their immense support to organize this event, and a very special mention to our sponsor, Goodwe, for being our crusaders here. I would now request my team to play the commercial video for Goodwe. Thank you so much, team, for playing that commercial video for Goodwe. May I now introduce Mr. Jeffrey Zinn, Senior Solution Engineer, Goodwe Solar Academy, to share the presentation for his company. Over to you, Mr. Zinn.
Okay. Okay, can you see my screen?
Yes.
Okay. Hello, everyone. This is Jeffrey from the Solar Academy of Goodwill. Okay, regarding this symposium, I would like to share our industrial and commercial on-grid products and solution in Southeast Asia, as well as in spread with some of our insights and perspectives on the future application of the CII stereos. Okay, let's go start it. So this time, the topic I will divide into the four main parts. The first one is the application and the products. The second one is our company's solution in Southeast Asia. The third one is the product features, and the last one is some cases. All right, for Goodwill, we are not just a product that we make, but more of the service and an integrated platform. As you can see, we are not only have the star product inverter, but also related accessories and the platform, and the products are more complete. We are committed to providing users with a full range of solutions, which is also our company's business philosophy. For example, in order to adapt to the market demand, we will launch new inverters to adapt to more module models in Thailand. In order to interface with different third-party equipment, we will integrate the new digital logger device and so on, such as in Malaysia and the Vietnam. We should launch the new the Easy Logger, the third version Easy Logger for the third-party meter or other devices to upload the data and the communication. Okay, the topology of the industrial and the commercial scenario is a very typical use case. The inverter generates electricity and the AC current, and then the load consumes or uploads it to the grid. The data is uploaded to the cloud portal through the different communication devices for monitoring and management. Of course, in some areas, such as the Philippines, where the low voltage access to the grid is required, the corresponding products are already in use. For larger scale industry and commercial projects, not only do they need to be modified in terms of output voltage, but some communication methods also need to be added to them, such as support for the PLC communication. Okay, here is the brief description of the specific of Goodwill solution in each section. Okay, for the communication part, we firstly use the Wi-Fi and the LAN dongle in industry and commercial project. This kind of network is simple, fast configuration, and is maintenance configuration in foreign projects. We will continue to update the second version for more stable connection. Okay, the 4G communication reduced in the limitation of equipment and the wires and the cables. Currently is more used in China and Australia and the European countries. If needed in the Southeast regions, we will match the local operators and publish the corresponding region-specific modules of 4G communication. Okay, between the inverter and the digital logger, the general use of IS-485 communication. This communication logic is simple, relatively stable, and reduce the data packet loss. Okay, as just mentioned, the PLC, the communication is also available for the high voltage or the large industrial or commercial projects. Two of the most important functions in the practice, in the power limit and the monitoring. Goodway has taken most of the current scenarios into account in this regard and has developed different solutions and supporting equipment. Without going to the detail here, you can see that we are very detailed and specific about the different scenarios. Okay, the first one, you can see the single inverter with the three-phase solution. And sorry, this one is just used for the smaller current of the smaller CNI project, and this one is for the larger CNI project. Must use special measures such as GM without neutralize. Also in some areas in Vietnam, because the medium voltage side export power limit solution should be needed. So we launched the new EasyLogger, the EasyLogger 3000C, and adapted to the GM330 meter to test the current or the voltage from the high voltage. And also the second solution is another solution for the medium voltage side export power limit. At the same time, for the monitoring with the meter at night power supply function, it is also available. It is also able to be designed differently according to the needs. And also for the multi-inverter solution, we use our integrated logger that called the SEC 1000 to connect up to 60 inverters to control the power output and monitoring. Also, the SCADA system used on the ground is interfaced to the platform through the use of IEC 104 protocol. And this diagram showed our products for the CNN products and adapted to the different scenarios for the SCADA use. Okay. The rest are some special scenario cases. For example, users can choose to use other brands of digital logger. We can open inverter Modbus protocol content to meet the communication established, and the products that have been tested so far are from the SolarLog, such as the SolarLog and the Metro Control. Meanwhile, the Goodway supports the direct or forwarding the data to the third-party platforms. And we can directly the data from the inverter to the third-party monitoring platform, or why use the API, the Kafka method from our portal called SAMS and to the third-party monitoring platform. Okay, finally, for some unstable the areas of the power grid, such as the Myanmar, with the use of the third-party controller can be similar to such as the diesel generators and other equipment together with the PV system to achieve the grid switching. Okay, so what should be the most essential features as an inverter? Yes, I think the safety and the protection is the most important, whether it's Goodway or other brand. These are measures that we are always improving and adding to in order to just generate power safely. Okay, the first one, the AFCI, for example, the short time arc extinguishing. Also, the IST feature can be added to protect the maintenance and some the firefighters after the shutdown the inverter. And the SPD protection on the DC and the AC side, and as the default, Goodway inverters can meet the Type 2, the SPD level, and if in some areas there are special needs for the Type 3, and we can meet them. Yeah. Okay, reasonable heat dissipation system and the fan design to ensure the relative good temperature rise and the follow. Also included is the fact that we test and report according the design and before the shipment. Okay. Such as the agent test and the ATS test. Okay, in some hot and the humid environments in the Southeast Asia, the negative the modules will lose electrons of the Earth, which will cause the modules derating rapidly, especially in the floating projects. And the inverters with PID recovery and external PID requirement can repair the PID problem efficiently. And in conjunction with the use of the aluminum cable in some areas, Goodway offers the copper and aluminum convention terminals to accommodate port connection and reduce the risk. All right, above you can see that the Goodway's approach to the scenario application and the equipment design is to adapt to customer needs as well as market trends, which has led us to have so many successful cases around the world. Here is just a brief display of a few case photos for your reference in China and some Southeast Asia and worldwide. Okay, there's some cases in China and Malaysia with a different model of inverters and accessories. Also, our southeast province in China, like in Yunnan province. Also, the climate change with the humidity and the hot. Okay, thank you for attending my presentation. I think Goodway has always been committed to providing more comprehensive solutions for the users. And I think we will always doing some help and some expected the solutions for the users or the client. So please free to contact us if you have any questions. Okay, thank you.
Thank you so much, Mr. Zim. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A box, and our speakers will answer those questions at the end of the panel discussion. So, let's dive into the world of PV technology now. So, Southeast Asia's solar industry is on the cusp of monumental change, and this webinar is your gateway to staying at the forefront of innovation. So let's stay at the forefront of the solar energy revolution by gaining insights into the latest developments in PV technology. Learn how to optimize solar projects, improve efficiency, and make informed decisions about technology choices. In this webinar, we bring together experts, thought leaders, and innovators to explore the next gen solar landscape. Our expert speakers will delve into solutions and discuss recent advancements in solar technologies. So don't miss this opportunity to dive into the future of solar energy in Southeast Asia. Without further ado, please allow me to introduce the elite panel for today. We have Mr. Bancha Yatip, Energy Consultant, Dr. Hao Wuba, Specialist Power Engineer, Super Energy Corporation, and Mr. Milan Koev, CEO, Hexagon Peak. Mr. Milan Koev, CEO, Hexagon Peak, will be the moderator for this session. Uh, Mr. Milan has been facing a few technical issues, so he will be joining us soon. In the meantime, may I request Mr. Banchayatip to give his introduction, and then we can have Dr. Hawbuba's introduction.
Thank you, Solar Force Quarter, and thank you, everyone, to join meeting today seminar. Thank you, Goodway, Jeffrey. Very, very good, interesting for the inverter Goodway, and thank you, everyone, to join to be here. Thank you very much, and Bancha, freelance energy and engineering consultant. Thank you very much. Okay, next one to.
Thank you so much, Mr. Bancha. Dr. Hawbuba, if you could introduce yourself.
Yes, hello everyone. So first of all, I would like to say thank you so much, Solar Quarter and Goodwe, for having me on board for our panel discussion today. So I would like to briefly introduce myself and our corporation. I'm Hậu Vuba, a power system analysis manager from Super Energy Corporation. Super Energy, as you may probably know about us, Super Energy is from Thailand as a renewable energy investor. And in Southeast Asia at present, we are mainly in Vietnam and in Thailand. So far, we have invested in solar power, wind power, battery energy storage systems, and waste to energy, mainly in Thailand. And regarding to our renewable energy asset portfolio, at present, we have around 1.4 gigawatt solar farms in Vietnam and in Thailand. We have a 50 megawatt onshore wind farm in Vietnam and 136 megawatt hour battery energy storage systems in Thailand, which are all already in operation. And in the meantime, Super Energy, we are developing around 400 megawatt nearshore and onshore wind power in Vietnam. So, and more hybrid PV and battery energy storage systems in Thailand, because there in Thailand we have a very clear mechanisms for development of battery energy storage systems. And today it is my great honor to join our panel discussion to talk about the latest developments in PV technology in Southeast Asia. And on my side, I can share some latest information of Vietnam And on behalf of Super Energy as a renewable energy asset owner, so we would like to share our perspectives and expectations for the latest developments in PV technology.
Thank you so much, Dr. Haruba, for that impressive portfolio that you just told us about. So I believe Mr. Milan is still facing a few technical issues in joining. In the meantime, Mr. Bancha, if you could enrich us with your perspectives of the current state of the solar industry in Southeast Asia region.
Okay, thank you. I would like to explain about the Southeast Asia PV solar panel technology in Asia and the market in Southeast Asia very growth. For example, in Thailand, I behalf of Cancun Engineering, we got the big large new project coming next year to 800 megawatt solar and wind farm, and solar plus PV plus BESS battery energy storage. Regarding Dr. Hua, who by says in Vietnam very close, and in Thailand also we have big project for solar floating from by EGAT owner and solar plus BESS or 1 gigawatt and 2.6 gigawatt solar is coming in Thailand. It's a big market in Southeast Asia and also Indonesia, Philippines, and Vietnam. Okay, we know very well. And Cambodia under developed by the ADB is the owner, is the banker to issue to Donia Group from German to like a lender engineer. I think this is a good opportunity for developer, for EPC, for supplier PV or investor. Is go there to Southeast Asia. It must be welcome, warm welcome. Thank you very much.
Thank you so much for sharing your perspective. It's really insightful. Dr. Haguba, if you could also share your perspective in this matter.
Yes, thank you very much. So, from my side, I can share some latest information of solar industry in Vietnam. So, according to the statistics, at the end of 2022, the total installed capacity of solar power in Vietnam reached 17 gigawatts, including both solar farms, utility scale, and solar rooftop solar systems. And as you may probably know, just a few months ago, very recently in May 2023, the latest power development plan, we call Power Development Plan number 8, PDP 8 of Vietnam, was approved with very ambitious targets towards renewable energy development in Vietnam to reach our net zero commitment in 2050. So, one of the key thing is in that power development plan, the target is by 2030, we may reach 50% of commercial and industrial residential building have rooftop solar systems for self-consumption. So at the beginning of our webinar, we see that GoodGui presented very good solution for CNI, commercial and industrial customers. So I guess GoodGui is also pay high attention for Vietnam market, as I guess that in coming years, the solutions of rooftop solar combined with battery energy storage systems for self-consumption will be a very hot market in Vietnam. So GoodGui or other suppliers, I think they are like preparing very well to provide cutting edge solutions for Vietnam market. And also good we also presented about like power limit controller that is for self-consumption system. So for the self-consumption system, we require a very special control scheme, which is called zero export in Vietnam. Zero export means the power generation from PV system is sufficient to supply the load only when the PV generation is higher than the load, then the system must be able to limit the PV generation so that no and electricity is exported to the grid. And this is because I think actually at present in Vietnam, the transmission grid remains a bottleneck for uh, solar and wind power development. So to encourage the development of renewable energy, the government emphasizes the development of solar and battery energy storage systems for self-consumption in commercial, industrial, and residential buildings.
Thank you. That was a great insight into the upcoming technologies in the solar sector. Here, I would like to, ask Mr. Banja here if you would like to weigh in on your thoughts about what are the upcoming technologies in the solar industry.
Okay, it's a good question. Is technology is coming to a peer-to-peer energy trading by virtual power plants? This is the uh, key success to develop to solar plus BESS and wind plus BESS and manage and energy management by microgrid and virtual power plants becoming to energy trading. Right now in Thailand, EGAT under testing the pilot project ERC sandbox with the trading energy together, three locations to buy and sell energy trading by using by blockchain. This is coming, and battery energy storage must be works with the solar panel and solar farm and solar rooftop or solar floating. In Thailand, many projects in EGAT, for example, to solar floating at dam, we put solar and battery energy storage, fuel cell, and EMS managed by microgrid. EGAT would like to check and control the demand response and forecast the renewable energy is a come like increase more and more energy come from the renewable energy. That's why EGAT would like to check and catch up the energy come from renewable energy. And the new technology is coming is focused on peer-to-peer energy trading and blockchain. This is the key point to success in the future. And BESS habitat also it means like you lengthen the battery energy storage and sell electricity by electricity, and BESS work with the PV, the PV and controlled by inverter and PCS power conversion system. This is the energy and technology trend is coming. Thank you.
Thank you so much, sir. Dr. Hawiba, what would be the expectations of developers with these new technologies and the upcoming ones which are just introduced, these technologies which you were talking about?
Yes. So I think recently, I mean, in the past years, the developers or manufacturers, we see like rapid and very significant changes or improvements in PV technologies. So the first thing we can emphasize is the efficiency of PV panels. So back to around 2019, our first solar farms, our first solar projects in Vietnam, so at that time, the efficiency of PV panels was just around 17 point something percent. And you see now in 2023, the efficiency of PV panel already reached 22 point something or 23%. And that is very significant. The design of system configuration can be very, really more optimal compared to the previous configuration design. And with the new PV technologies, it is guessed that in around 2025, the efficiency of PV panel will reach around 26 point something percent. And it is expected that the efficiency of PV panel will reach more than 30% in the long term with the development of new technologies. And also, in the past years, we observed significant transitions in PV technologies from mass production in polycrystalline PV cells to monocrystalline PV cells. And also, recently, we observed a big technological changes from P-type solar cells to N-type solar cells. So basically, solar cells were significantly more expensive than P-type. And in the past years, we observed mass production of P-type PV cells. But many experts, we see that in the third quarter of this year, third quarter of 2023, the mass production of N-type PV cell will start and gradually increase, and thereby the mass production of P-type solar cells will gradually decrease. So, like basically, we observe big changes, big updates in the PV technologies in terms of the technology itself and in terms of the efficiency. So, for the developers, for sure, we have to update ourselves with the latest developments in PV technology industries. So the key reason is we have to follow the technology development so that we can see how our assets will be designed in the future. I mean, how our solar assets, our solar farms, our solar system will be designed in the future in the most optimal way. Yes, and also, as Mr. Bancha mentioned, a battery energy storage system combined with PV systems could be one of the key development trends in the next years. So, as I already emphasized in the previous sharing, Vietnam, we are prioritizing the combination of solar systems combined with battery energy storage system to solve some critical problems of PV generation systems, such as the intermittency of solar irradiance. So I also saw that GoodGui they provided their solution combined with battery energy storage systems. So I see that these days in exhibitions and conferences in Vietnam, many suppliers they come to Vietnam to present their cutting edge solutions for solar systems combined with battery energy storage systems. That will be one of the key trends in the coming years.
That was a great insight into the key trends. While I have you here, Dr. Havuba, I would also like to ask you what are some of the challenges that are faced by developers while transitioning from previous technologies that were currently used to new technologies that are introduced. As you mentioned, the P cells were in mass production, but now there's a new technology of N cells, and gradually everyone would be moving towards them. So, what are the challenges faced in these kind of transitions?
Yes. So, like before talking about the challenges, I would like to emphasize again, for sure, with like technological development, the system configuration, the system design will be more optimal in the future, and the asset performance will be significantly enhanced in the future. However, from the perspective of renewable asset owner, we are facing some challenges in to manage our existing solar assets. So just for example, some years ago in our the original design of our solar farm, we use PV panels with the rated power of 330 watts. And at present, we have no problem with spare parts, spare equipment. However, I guess that in the next 5 years, all of the asset owners like Super Energy, we will face significant challenges in preparing the spare parts to replace any faulty PV panels in our existing system. Uh, as you may probably know, in our some legal registration documents, we have to register clearly how many PV panels in our solar farms and which is the rated capacity, the rated power of each PV panels. So once we have to change the configuration, we have to update some legal registration documents again. So that is one of the first challenge that I can share from the perspective of developer or asset owner. And the second challenge, I think even more severe challenge that we are facing is related to the inverter technology. So the same as PV technologies, I guess that in the next 5 years, some like components inside the converters may not have like available spare parts in the market. So at present, we have no problems with the spare part. The supply chain, the manufacturing chain is still working, and we can buy spare parts easily. But in the next year, some spare parts inside the inverter, it will be challenging to have to prepare for the spare parts. And for the inverter, it will be like more severe when when we change the inverter model. All the like legal registration documents must be updated. The monitoring and control system must be updated accordingly to match with the new PV inverter technology. So basically, these are the main challenges that we are facing, basically related to the spare parts in the long term. Yeah.
So I believe these would also be the factors which go into consideration when deciding the new technologies to be implemented, right? Okay, so here, Mr. Banja, I would like for you to weigh in. What other factors, developers consider when choosing the most suitable technology for their projects?
Can please question.
Yes. So, what are the factors that developers consider before choosing the right technologies for their projects?
Okay, thank you for question. I think is the main lesson the developer must be concentrate is the policy and technology. Right now, as we recognize about the micro inverter have the three micro inverter and inverter hybrid PV and combined with the BESS is very important is coming because the performance is guaranteed by the how many kilowatt hour or unit of the electricity generated. This is the key point for the technology is must be support PPA because the PPA is must be the cost of the electricity. Sometimes we developer uh, concerned about the feed in tariff. It's very cheap and very small cost, and that's why technology is must be support. I think AI, artificial intelligence, is must be key important also because AI will forecast in the future how many megawatt, how many electricity generated those areas. It means technology is must be support solar and wind and BESS, including the policy of the government. For example, in Thailand, the policy by Apple, Energy Policy and Planning Officer, uh, announced that 4D 1E is mean decentralized digital and energy management system is must be concerned and control the distributed energy resource. For example, for solar, wind, and battery essential storage, biomass and biogas, and managed by the microgrid and virtual power plant. And the finally is peer-to-peer is coming. This is the key point for policy and technology. Thank you.
Thank you. Sir, additionally, I would like to ask you if you would like to add to any of the challenges that Dr. Habuba illustrated that developers face when transitioning from existing technologies to new developments. Would you like to add any of the challenges mentioned by him? Or Mr. Banja?
Sorry again, please. Okay. Sorry again, please. The question. Thank you.
Yes, so as Dr. Abuba just explained to us some of the legal challenges that they face when when transitioning from existing technologies to new developments. Would you also agree or like to add to any of those challenges mentioned by him?
I'm mostly agree 100% with Dr. Buba because in Vietnam and in Thailand is the same with PDP development plan, power plan. In Thailand, 2018, the PDP was revision version 1, and right now revision already 2022. It must be developed and including the new technologies coming like emerging technology, for example, behind the meter, energy storage, and cloud computing, big data, home energy management, or demand response, and electric vehicle. And the new technology feature is coming is AI, machine learning, DERMS, energy management system, and blockchain, IoT, VP, virtual power plant, and smart data edge computing. This is the technology is coming. This is the point for like we adapt conventional solar and wind. For example, solar and wind become uh, to new feature to technology. Thank you. Thank you.
Thank you, sir. Dr. Habuba, I would like to know that what are the strategies that are employed by developers to mitigate some of the challenges, as you mentioned, while transitioning to new technologies to meet the deadlines and budget requirements? How do you mitigate those issues?
Yes, thank you for your question. So before answering your question, I would like to add some like perspective, add some information to the question given to Mr. Bancha. So like absolutely, Mr. Bancha shared with us a very key important point, the correlation between technology and regulation. So basically, regulation and technology, they must support each other to make the investment feasible, economically feasible, and technically feasible. So uh, mm, Mr. Bancha also mentioned about the support of artificial intelligence in the future in renewable energy in general or in solar power development in particular. So I totally agree with Mr. Bancha. I just would like to add some more information. So, for example, in Vietnam, in super energy, we have utility scale solar farms connected to the national transmission grid of Vietnam. And by the regulations, we have to submit our solar power generation forecast for week ahead, day ahead, and hour ahead to the national load dispatch center. So, in this case, for sure, if we have like a highly accurate forecasting model based on AI technology, it really supports us a lot to optimize and enhance our renewable energy asset performance. And also, one of like the other key thing that I would like to emphasize is the support of AI and data analytics in like the performance assessment of solar asset to support the operators to perform predictive maintenance. So in the next few years, I guess in the next 2 or 3 years, predictive maintenance will be a very hot area for solar and wind asset management, sustainable solar and wind asset management. Predictive maintenance help us to see the inside of our asset health conditions. Thereby, we can have very timely predictive maintenance actions to protect, to enhance the performance of our solar asset. So now I would like to get back to the question. I would like to share our strategies to to face to handle the challenges in technology transition. So I would like to emphasize on the effects of new technologies first. So when we have to consider the effects of the new technologies on our project development, so one of the first thing we have to analyze is the technical advantages that the new technology brings to us. So from there, we can see how our asset performance will behave in the long term, and from there we can we can conduct a very solid and accurate cost benefit analysis to decide our investment. And as I mentioned, with the development of new technologies and for sure with better performance, then our system design will be more optimal. And for long term, we can have better performance of solar systems. And the other consideration is the market availability. For example, if we select a very high efficiency PV technology, but we have to consider the market availability. Even that product is available in the market, but not in large scale yet. So we face very certain risks if we go for that technology. So now I would like to share I can say that very sustainable strategies to handle with energy technological transition in this area. So our strategy is we have in-house innovation team that who actively study and update with the latest development in solar and wind power technologies. And to be honest, like Super Energy, we are renewable energy investor and asset owner. We are not manufacturer. So for sure, compared to technology manufacturer, we don't have that big R&D or innovation team. But we have the innovation team. Maybe not many people, but our engineering capacity is must be very competitive, must be very strong. So in our innovation team, we must update the latest developments of technologies so we can see that in the long term how our system, how our assets need to be updated. So even from now, we already have some plans to update our renewable energy asset in the future. So we keep adapting with the changes in technologies. That is, I think, one of the most sustainable way how a set owner or developer should adapt to the new technologies.
Thank you so much, Dr. Havuba. It's very well said how we must do our own studies as well to mitigate those challenges that are faced during the transitioning period. And here, I would like to call upon Mr. Bancha as well. If he would like to share his perspectives on how to mitigate some of these challenges during transitioning from existing technologies to new ones.
Thank you for question. For my idea, I think is the point very important also. Standard IEC 61850. This is the standard using for the developing renovate the existing the substation. The substation is long time ago, maybe 30 more than 30 years. They use the low technology. It's like a relay or governor. In Thailand, the energy system like this, the single enhanced buyer by EGAT monopoly is generating and produce electricity and sell to PEA and MEA distributor. And PEA have the substation 670 substation right now. The substation until the long time 30 years ago already it must be developed and renovate substation by using by standard IEC 61850 to catch up and check and forecasting about the renewable energy coming to feeder is substation. It must be controlled and they would like to command the new energy come from RE and in the future maybe come and check and become to digital twin. Digital twin it means we use digital and virtual power plant. Virtual power plant is comparison is like a virtual and actual. Virtual it means we 100% like in idea. For in the action, it means the production, the electricity, how many kilowatt or megawatt we action, the production in action. And then IEC standard 61850 is the combine with the power and IoT and human interface and controlled by SCADA SCADA monitoring and SCADA control and access to renewable energy. Every source is like a resource for wind farm or solar farm or biomass or battery energy storage. Control access by SCADA come from the new substation after renovate already by IEC 61850. We can catch up the energy come from IE. This is a point it must be checked and develop the existing substation also. Thank you.
Thank you so much. So those were some insightful points given by Mr. Bancha. So before we proceed to our question and answer round, Dr. Habuba, if you would like to give some closing remarks.
Yes, so by the way, Mr. Bancha is talking about some, I mean, like system automation or substation automation. I would like to add some points of the new technologies, how it is affecting the way that we manage our asset. So, like today, we are talking about PV technology, but I think we can also talk about like solutions that we can manage our PV or solar assets better. So these days, see that like in webinars, in seminars, in conferences, people are talking a lot about digital solutions for solar asset or renewable energy asset management. So I can share one of the strategies that Super Energy we are considering. We are actually implementing. That is the implementation of Operation Control Center. So, like in Vietnam, by the regulations, if we implement an operation control center (OCC), and from there we can remotely control the substations and power plants under the control authority. So basically, we can reduce the manpower at the substation or at the power plants. So basically, we can save the cost for manpower significantly. And one of the key technologies which really supports the implementation of OCC is the application of artificial intelligence to analyze our asset performance remotely and to analyze the health conditions of our asset for predictive maintenance remotely, so we can allocate our human resource, we can allocate our equipment resource optimally. So that is one of the key strategies that Super Energy we are considering and implementing to improve our solar asset management sustainably. Yes, so as you per your request, I would like to have some remarks on our panel discussion. So from the presentation, we see that Mr. Sin from GoodGui presented to us some of key solutions in PV technology and battery energy storage system technology for CNI, for commercial and industrial customers. So I do not know exactly how about other countries, but in Vietnam, in the next few years, in the coming years, the solutions of rooftop solar systems combined with battery energy storage system will be very promising for commercial and industrial CNI customers. That is the first point. And the second point is like over the past years, we observe significant changes, significant improvements in the technology related to PV panels, related to PV inverters. So I think for a set owner or developers, we have to find our own sustainable strategies to adapt with the transitions, the positive transitions in technology development. And also, the third point that I would like to recall to emphasize is the support. I mean, the importance of data-driven solutions for sustainable solar asset management, particularly the support of artificial intelligence, which can support us to analyze the very rich historical operational data to give us actionable insight of our asset performance and health conditions. Thereby, we can manage our asset in most optimal way. Yes.
Thank you so much. That was very interesting and impactful what you just said. I'm sure it's given us a lot to think about. Mr. Banja, if you would like to add any closing remarks before we move to the question and answer session.
I think Dr. Huba is very clear, explain more clear. Thank you very much. I agree, Dr. Huba, and I would like to suggest something. When we do project some like a solar rooftop or solar farm, we must be consider the material cost and operating cost. Operating cost is mean labor cost installation. Material cost is must be use the good quality the material like inverter and PV the tier one or cable or DC combiner, AC combiner, and the cable also. And we focus on the quality first, and then control cost and time, and many important is the safety. EPC mostly avoid safety is the dangerous because we double cost or double time to use it spend it again. I think EPC and developer is focused on the quality is the good because the technology change it very quickly, but the installer it mean EPC and contractor is must be safe, uh, safety and quality is the key point to success for the mostly our farm outsourced by O&M team, and then we focus and monitoring the quality first, and the second we keep the fair price and fair good cost to O&M team, and we have in-house and out-house and outsource also, and that's why we must focus on the safety and the quality. Yes, thank you very much.
Thank you so much, Mr. Bancha. Thank you so much, Dr. Havuba. It has been an incredible and insightful session with you both. Now let's move on to some of the questions that have been posted by our audience. So this is a question for Dr. Havuba. Can you explain Thailand, Vietnam, and other Asian governments' incentives or tax benefits for clean tech product companies like us? HD batteries, dual electric EVs, and infratech for commercial EVs like bus, trucks, ships, buildings, etc.
Yes, thank you, the audience, for your question. I think from my side, I can share only the information from Vietnam. I do not have rich information from Thailand or other ASEAN countries. So, as I know that in Vietnam, so for example, if you are renewable energy investor, then you can. So the first incentive that we can mention is about the feed-in tariff. But however, the feed-in tariff for rooftop solar for solar farms already expired in Vietnam, and all related parties we are waiting for the new mechanisms. And the new mechanisms can be the next feed-in tariff mechanism, or it can be auction mechanism, like bidding mechanism for renewable energy projects. In addition to that, the renewable energy enterprises, they can receive the import tax exemption, and they can also receive the corporate income tax exemption. Particularly, the corporate income tax can be exempted for the first 4 years, and they can receive 50% reduction for the next 9 years. And for clean tech product companies like battery manufacturer, EV manufacturers, for sure, if you are clean tech product companies in Vietnam, you can receive the reduction in corporate income tax, and also you can receive the reduction in the import tax. Yes.
Thank you so much, Dr. Habuba. Uh, I believe that is all the questions we have for today. Um, I'll just see if there are some last minute entries. Yes, we have one more. So, how we can improve forecasting accuracy considering high cloud movement?
Yes, so I think I can like provide my perspective, my answer for this question. After that, Mr. Banchan can add more information if any. So the question is how we can improve forecasting accuracy considering high cloud movements. So according to my humble observations, we have around three forecasting models for solar farms. The first forecasting model is based on numerical weather prediction, which is suitable for like day ahead, week ahead solar irradiance forecasting and power generation forecasting. The other model is time series forecasting based on recent historical measurement data, which is very suitable for day hour ahead forecasting. And particularly, this question is related to the high cloud movement. So this is related to a very short term solar power forecasting, particularly can be like 30 minutes ahead or hour ahead. So according to my reading, there is a very important solution for this forecasting challenging is image we can use the total sky image that we can capture the picture of the whole sky, and from there we can analyze the movement direction of cloud, and from there we can analyze and calculate the the directions, the movement directions of the cloud, and then we can estimate the shading effect on our solar farms. And that is, I think, one of the latest technologies to handle the very short term solar irradiance or solar power forecasting, considering like high cloud movements. And in that technology, AI can support us a lot. AI can handle the analytics, can handle the image processing to estimate the cloud movement, and also can handle all of the time series data and output, I think, highly accurate forecasting result for us.
Thank you. Mr. Banja, would you like to add to that?
Thank you. I agree. Dr. Huba says, I would like to explain for more ask for more information for forecast. Right now, EGAT setting the RE forecast for forecast solar farm every 15 minutes for real time by check and using by AI. For rooftops, 1 minute, like nearly near time. I think ECAT would like to develop the software AI for real time monitoring. Solar farm right now, 15 minutes, okay, check and respond every 15 minutes, every 15 minutes, but they try to use rooftop every 1 minute, 1 minute, 1 minute. AI is must be like a calculator or software to developing it fast and learning it like a super semiconductor, something like that. In the future, hardware and software must be developing to catch up and forecast it like real time. Uh, Thank you.
Thank you so much. And let me check for any last moment questions that are added. So we have one more question. What is the latest status of Vietnam's RE programs? What measures were taken to address the grid issues previously? Dr. Havuba, I believe this comes under your expertise.
Yes. So about the latest status of Vietnam related to renewable energy programs. So according to the latest power development plan, the PDP-8 was approved a few months ago. So for the renewable energy programs, the government will prioritize the wind power more than solar powers in the coming years. So however, in the coming years for the solar area, there will be a priority for rooftop solar systems combined with battery energy storage systems for CNI customers. And to be honest, up to now, we don't have, I think all of us, all of the related parties from developers, solution suppliers, and investors, we are waiting for the new mechanism from the government in I think in very short term, can be in early next year. so that we can develop new projects related to rooftop solar systems and wind systems. And about the solutions to address the grid issues previously. So as you may probably now know about Vietnam now, the the capacity of the transmission grid remains one of the key bottleneck for renewable energy development in Vietnam. And actually, but the national grid is very, it is securely protected and controlled by the automatic generation control system operated by the National Load Dispatch Center. However, the grid curtailment remains, a big concern for investors and owners in Vietnam. And actually, in the PDP-8, there is a very clear plan to update the national transmission grid. So, however, as you also can guess that, the construction, the design and construction of transmission grids takes years. So we hope that, like in the next 2 or 3 years, the problem of transmission grid can be solved partly or completely. And also, one more solution is to deploy a battery energy storage system in some in some particular areas to solve the weakness of the transmission grid. Then the renewable energy penetration can grow higher in the few years in the future.
Thank you. We have one more question that has just come in. How about carbon credit or REC market across SEA region? Mr. Bancha, would you like to take this question?
Okay, it's a good question for carbon credit. I think it's very important in the future because as we recognize about CBAM, Carbon Border Act, this is the effect to the factory uh, production to export to Europe. Uh, as the Dr. Huba mentioned about the like in Thailand we have the BOI and we have the subsidy by the battery and VAT and import tax. And also we merely have the renewable energy certificate. In Southeast Asia region, bond credit will increase more and more, and the price is very high and high because its demand very important because CBAM start from the 1st of October 2023. This is year for the effect to the factory who is the export to Europe. This is that's why the carbon credit is must be need and need to be like solution scope 1, scope 2, or scope 3. Right now, ILEX scope 2, ILEX International Renewable Energy Certificate, very important because some agent or dealer need to buy legs from solar and wind farm in Thailand. I think in the future, the price of the carbon credit or legs will be increased and the price and demand increase sure in the future. Thank you.
Yes, thank you. I think I can add some more information to this question. So, like in Vietnam at present, we don't have like the platform of the framework for carbon credit trading or a renewable energy certificate market yet. But as far as I know, in Thailand, you have very clear framework and platform for carbon credit trading, and like renewable energy certificates is very popular in Singapore now. And just out of Southeast Asia region, for example, in South Korea, the the price of renewable energy certificates is already included in the bidding process. So I think that is one of the very interesting policy that Southeast Asia region we can learn from other country.
Thank you so much. That was quite an insightful session, and very insightful viewpoints that have been used to answer these questions. So, with that, we have come to the end of our questions. Oh, we have one last minute question posted. Uh, does this also apply to Japan?
I think I don't have the information of Japan. Yes.
Sure.
Okay, I
So,
would like to explain also in apply to Japan also because we have solar farm in Japan, in Sendai, and REC we apply and setting agent for the carbon credit use apply in Japan also. Thank you.
thank you so much, Mr. Banja. So, with that, we've come to the end of all our questions. Thank you so much to our esteemed speakers, Dr. Hawuba, Mr. Banja. Thank you so much. It has been quite an insightful session. A big shout out to our attendees, and a very special thanks to our sponsor, Goodwe, for their immense support to organize this event. We promise you to come back soon with more exciting sessions. Thank you all. The floor is now open for networking.
Thank you so much. Thank you, everyone.
Thank you.